Alright, okay, welcome to your first A2 revision session on research methods. So this is a nice easy one. There's only content analysis and case studies, which are A2 content, and they're not really true A2 content. You would have been more than capable at AS at looking at them as well. So we're going to go through experimental methods, observational techniques, self-report, correlation, content analysis, and case studies. Now with this video it's slightly different from the other ones because it's a revision one. So what I'd like you to do is every time that I flash up on the screen like an exam command word such as describe or evaluate, I would like you to pause the video there for a moment and make as many notes as you can. Otherwise this is completely useless. So the way to make it the most effective is testing your knowledge every time. Otherwise, if you're anything like me, you will find that you'll half watch the video but then you get distracted by something else. You'll send a text message, have a quick check Facebook, whatever it might be, and it won't go in. Whereas if you do exactly what you need to do, which is remember as much as you possibly can from the instruction on the screen, then change your pen over, add any additional notes as we go through. So if there's anything you missed, you can add those in. Then you can look at your notes and you think, oh, I know all of this, this is absolutely fine, this is mostly in pencil, whereas I've had to add 3 or 4 things in pen, so that's fine. Whereas this is, wow, this is mostly pen, there's absolutely nothing that I knew that I could remember that I didn't make notes on. So please make the use of this the best that you can, rather than just being passive and not really kind of taking it in, because if you're dedicating some time to watch this video to do some revision, that's excellent. Please make the most of it as possible. If you don't, it's just wasting that time. So please think really carefully about that. First thing I would like you to do then is have a quick think about this table and see how much you can fill in from it. So you've got lab, field, natural and quasi, and you need to think about random allocation, think about IV manipulation, controlled environment, and was the IV planned? What can you put in each one of those? Okay, so if you pause the video here, have a quick go at making some notes, and then you can have a look through the answers. So if we have a quick look at that table then, of course, lab studies you can randomly allocate, and we will come to that in one of the other videos we look at where we talk about controls. So you can randomly take a group of 100 people and randomly allocate 50 to take caffeine and 50 to not take caffeine, or you can randomly allocate 15 to watch a violent TV show and 50 to watch a non-violent TV show, whatever it might be. And of course you'd randomly allocate in lots of different ways, but by putting all of the names into a hat, drawing out 50 names and they'd be condition 1, and then 50 names and they'd be condition 2, or drawing out one name condition 1, drawing out the second name condition 2, and so on. So that can be done. The IV can be manipulated. We can choose the IV, we pick the IV and we manipulate it and choose it. So we give certain people caffeine, we don't give certain people caffeine. That's our manipulation. It's in a controlled environment, it's in a lab, and the IV is planned. We know exactly what we are going to look at when we conduct the experiment. We think this is what we're going to look at, and then we conduct an experiment. Field, so the way that that's similar to a lab, you can randomly allocate. Once again, you can randomly allocate so many people to do one thing and so many people to do another. The IV can be manipulated. We are in full control of the IV. We can select who does and who doesn't experience condition 1 or condition 2. The difference between a lab and a field is a naturalistic environment. So whereas a lab is a very, very controlled environment, a field is much more naturalistic and true to the real life. And then the IV is planned. So again, we know exactly what's going to happen. We plan it, and that's the IV. Conduct the experiment. Natural experiments, these are different from both lab and field because you cannot randomly allocate. Because the IV is naturally occurring. So these are naturally occurring events that happen that we don't have any control over. So such as war, famine, earthquakes, generally quite unpleasant, unethical, things that would be unethical to recreate. So we have to take natural advantage of them. Another example might be a slightly more ethical one would be there was an island that didn't have the access to TV, so obviously over the years gradually TVs had come in through the 50s and 60s, lots of families started to get them. That was not the case in this island. In this island there was no TV, and suddenly it was introduced, so there was all the developments made, and then everybody very quickly got TVs and they wanted to explore what happened there. So IV was naturally occurring. it happened without any influence from us at all. We just observed as psychologists to see what would happen. Natural experiment, of course, natural environment, so that's how it's similar to a field. So different from a field because you can't randomly allocate and the IV is naturally occurring, but similar because it's a natural environment. And then the IV is unplanned, or what we'd say uncontrolled by the psychologist. The psychologist has no involvement with it. Again, unlike a field. And then we have quasi experiments. So just like a natural and different to a lab and a field, we cannot randomly allocate, and the IV is a quality of the participant. So if we had 100 people and we wanted to look at the difference between men and women's maths ability, you can't randomly allocate, you can't pull names out of a hat, right? You're going to be a man, you're going to be a woman. That is something, a quality that you have brought in with you. The same with possibly having Down syndrome, OCD, depression, what else? Eating disorders, anything that the participant brings with them, so can't be randomly allocated. So of course we can't get 100 people and say, right, you 50 you're going to develop eating disorders and you 50 aren't going to develop eating disorders. That's not how it works. However, the way that it is different to a natural, which makes it closer to a lab, is it's a controlled environment and it involves a planned IV. So we know what we're going to look at, we just can't randomly allocate, and the environment is very, very controlled. Key things that I would say: lab and field, you can randomly allocate both. The IV can be manipulated and it's planned, whereas natural and quasi you can't randomly allocate, which is the key difference between the two, and the IV isn't manipulated. However, a field and a natural are the two most similar. So a field you can randomly allocate and a natural you can't, but other than that they're both quite naturalistic environments, whereas a lab and a quasi are the most similar, as in for the environment, so it's a controlled environment. So do look carefully at that. Think, it's a lab, it takes place in a lab. Have a quick look at the IV, have a careful think about that. Okay, well done. See how many you've remembered. Pause, is there any you need to add in and remind yourself of? Next thing I would like you to do is evaluate lab and field studies. Okay, so if we have a look at experimental methods for lab and field, this should be a nice easy one for you, because we did it so much at AS that you should be confident with these. The key thing is don't forget to elaborate, point, example, explain, give that detail, talk about all those different terms. It's the explain sentence that will get you the marks, so please, please, please do elaborate on that. So of course lab experiments are a controlled environment. This is good because it reduces extraneous variables, so we can be more confident of cause and effect, which increases internal validity. Can randomly allocate, so that reduces confounding and participant variables, which increases the validity as well for that one. So with confounding variables, it would be the idea that for example, with Sperry's research, you've got split brain patients, so the IVs were looking at whether they were split brain or not, but a confounding variable, a variable that varies with whether they had a split brain or whether they didn't have a split brain, was the fact that everybody with a split brain also had epilepsy. We don't want to test for epilepsy, we just want to see the effects of split brain, so therefore by not being able to randomly allocate people to different conditions, we're kind of going to struggle with those confounding variables, which in the case of a lab study isn't a problem, so we can randomly allocate, which removes those the confounding variables and increases validity. We can be confident, again confident of cause and effect. And then we've got a problem with labs, lacks mundane realism, so a lot of the tasks are very artificial, the environment is very artificial, that can lead to demand characteristics and people acting unnaturally. If people are acting naturally, that's reducing the validity, so we're not measuring how much caffeine has an effect on memory or whatever it might be. We're measuring demand characteristics, the effect of demand characteristics on the DV, which we're not interested in. Therefore we can't generalise because we can't be confident. Then, as always, as we've talked about over and over again, you flip those two. So however, a strength of a field is it's high in mundane realism, so it's very true to real life, natural environment, natural tasks, therefore they act naturally. It reduces demand characteristics, which increases the validity. Because there's no demand characteristics, we are measuring whatever it is that we're measuring, the effect of the IV on the DV, and therefore those results can be generalised with confidence. We can be confident of cause and effect. Also, we can randomly allocate, so this is another one that's the strength of both lab and fields. We can randomly allocate, which reduces confounding variables and increases validity. However, a problem with the field is we have less control because it's a natural environment, so that increases extraneous variables, which calls into question cause and effect, and therefore reduces the internal validity. So it's a problem, we have to be careful how we generalise and use those results. Next, what I'd like to have a go at is evaluating natural and quasi studies. So you know everything about natural and quasi studies, you can tell me all about them. Now what I would like you to do is evaluate them. Okay, so that's a bit interesting. Obviously it's not quite worked when I was setting this up, but if we go through them, we've got natural experiments. So strength for natural is it allows us to study things that would be unethical to recreate as psychologists, so it's not ethically appropriate for us to create a war and then see how people respond to that, or put people through an earthquake or a terrorist attack and see how they respond psychologically. So natural experiments allow us to do that, therefore more likely to be approved by an ethics board, increases protection from harm, so allows us to conduct research that we wouldn't otherwise. High and mundane realism, so this is how it links to field, so all of these evaluation points are overlapping. High and mundane realism, so natural environment can act naturally, reduces domain characteristics, increase validity and therefore generalisability. However, with natural and with quasi, we cannot randomly allocate, so you'll see there, cannot randomly allocate to conditions, so we can't control for confounding variables, which leads to validity. So for example, the only thing that these people in common who've experienced an earthquake wouldn't just be the earthquake they've experienced, it might be the location if we're all from the same place, so that could be a confounding variable. There might be something specific to their culture which means they respond in a certain way as opposed to the fact they've been through an earthquake or whatever it might be. Strength of a quasi is controlled environment, so very, very similar to a lab. So controlled environments reduce extraneous variables, so you can be confident of cause and effect and internal validity. However, a weakness of a quasi, just like a weakness of a natural, is that you cannot randomly allocate to conditions, so it doesn't control for confounding variables. For example, people with eating disorders, it won't be necessarily whether they've experienced an eating disorder or not. Potentially, there are certain arguments that certain personality types might be linked to eating disorders, or what was I going to say? Certain genders maybe, being very stereotypical. So it might not be the fact that they've experienced the eating disorder that might cause them to respond differently to problem solving. It might be those confounding the variables that vary systematically with the IV. And then of course quasi lacks mundane realism, artificial task domain characteristics, so they act unnaturally and therefore we can't be confident of validity. Excellent. Next one, identify and describe the different types of observations. So get your paper out, make as many notes as you can in one colour, and then when we go through the information in a minute, add in anything that you've missed. And of course you can do this more than once to test your knowledge later on. So pause the video. Okay, types of observations then. We have overt and covert, participant and non-participant, and controlled and natural. Overt versus covert. Overt, it sounds like obvious. If you do something very overtly, it's very obvious, so some participants are aware they're taking part. Covert, you do it secretively, undercover, so covert, undercover, so they're not aware they're taking part. Participant, the experimenter, the observer themselves is involved in the task, so if it's a team building activity, building a tower out of spaghettis and marshmallows, or whatever it might be, then they're involved in that, one of the participants. Non-participant means that they sit back and they observe and they don't take part in the session. And they just watch. And then controlled and natural. Controlled environment means that we have had some control on the way the environment is, whereas a natural, we just observe people in their natural environments. A key thing here is a couple of pieces of terminology. It sounds really silly, but it's a mistake that happens all the time, and it makes you look less psychological than you actually are, because you're all excellent psychologists. Don't forget, an observer conducts an observation, an experimenter conducts an experiment. Do not talk about experimenters if you're talking about an observation. Do not talk about observers if you're talking about an experiment. So just bear that one in mind. Small thing makes a huge difference. Something else you need to be aware of, an experiment has an IV. So all of those 4 different types of experiments we've looked at, lab, field, natural, quasi, they all had IVs. We couldn't always randomly allocate to them, these different conditions, but all of them had an IV and a DV. An observation doesn't have an IV. Okay, if we're talking about IV and DV, or the 2 different conditions, it's not an observation, it's an experiment that uses an observational method. So for an observation, there is no comparison made between conditions. If there's an IV, then it's an experiment using observational methods, which is what we said. And then the difference between a controlled observation and an experiment is an IV. So be ever so careful there. Is it controlled observation or is it experiment? So do we alter the environment slightly? If that's the case, it's controlled observation. If there's a clear condition 1, condition 2, IV, then it is an experiment. So an experiment, the IV is a comparison between 2 groups. Which participant displays more helping behaviours? So you compare them. those who see a man with a cane fall over compared to those who see somebody drunk fall over. So that would be an experiment. You've got the two different IVs, whereas an observation, controlled observation, there's no comparison. So how many people help a man in the street who's fallen down? So there's the difference between the two. So the experiment there, we're talking about Pilyarvin, which is not necessarily something you need to be aware of, but a really interesting piece of research. They had people, a man with a cane appeared to fall over and a man who appeared to be drunk fall over, and there were a couple of other variables as well, whether they were black, whether they were white, and so on. They wanted to see whether people who would help was more likely to help. So they manufactured that. That was condition 1 and condition 2. And they compared those two, whereas a controlled observation, there wasn't a comparison. We still had control of the observation of the environment, so we altered it in some way. Someone fell over, and we wanted to see how many people would help, but we didn't have condition 1 and condition 2, so just no IV. Now what I'd like you to do is think of everything you can for behavioural categories. Tell me about them, what's important about them. Write that down, pause the video, write that down, and then check any notes and add anything on. Okay, behavioural categories. You've got unstructured observations, which record every single possible behaviour, and then structured observations, which is where your behavioural categories come in. Behavioural categories, they're essentially a behavioural checklist, breaking down behaviour into operationalised components, and the most important thing there is operationalised. So don't have them vague, don't be something like somebody looking happy, somebody looking sad. You must make it clear and precise, because what's an objective, so what one person thinks is somebody looking happy might not be somebody else's opinion of what something is happy. And you must make it measurable, you must make it countable. So if somebody looking happy, how do you measure that? How do you count that? It's how many times they smile, how many times they laugh, and so on and so on. Describe a behaviour, not an emotion. So don't say someone happy, say something that someone would do when they're happy. Don't say when somebody's sad. So every time their eyes, they start to cry, every time they look down at the ground, whatever it might be. So you wouldn't say depression, looking sad. If you were measuring depression, you wouldn't say looking sad, you would say crying. If you were measuring aggression, you wouldn't say looking angry, you'd say how many times they hit someone. If it's attachment, you wouldn't say how much they show affection, it would be how many times they put their arms around their shoulder, and so on. Okay, so the most important thing there, so many A2 students don't do that. It's an AS thing that AS students should be getting, but even at A2 they don't get it. So please make sure your behavioural categories are operationalised. Describe event and time sampling, write them down for me, and then we'll go through them. Okay, so event and time sampling. Event sampling, record every time an event or behaviour happens. So you have behavioural categories. Every time you see someone hitting someone, you tally it. Every time you see somebody crying, you tally it, and so on. So every time a child cries, every time a child hits someone. It's almost like I wrote these. Time sampling, record what is happening at a set time. So every 30 seconds record what's happening. Remember, we did these two different ones. So event sampling, we looked at Super Nanny, and every time the child did various things, every time they threw something, every time they hit somebody, every time they said a mean name, I think it was poo-poo head maybe, you would tally that down every time that happened. The other way we did it is every 20 seconds, I think it was, we watched the clip of the girl in the hospital that was linked to Peterson and Peterson. I think it was research, might not have been Peterson and Peterson. Somebody and somebody, they're a married couple, and every 20 seconds we'd pause it and we'd write down exactly what was happening. So little girl crying, watch it again, pause, little girl blowing nose, watch for another 20 seconds, and so on. The other way that it might work is, say, you would watch for the first 5 minutes of every hour, so 9 o'clock till 9:05, 10 o'clock till 10:05, and so on. Okay. Evaluate observation. So all of those things were linked to observation. Now what I would like you to do is evaluate observation as a whole. So pause the video. Okay, so observations, strengths. In comparison to self-report, experiments, things like that, observations are strong, they're good because it removes relying on people to report their behaviours. We can see natural behaviours such as aggression, and that increases the validity. So we don't need to ask someone, how aggressive are you? I'm not aggressive at all, never get angry. And then, whereas if you put them in an observation, give them something frustrating that might happen, you see lots and lots of angry behaviours. So it removes the need to rely on people, removes the need for self-awareness, really useful. The reason that just being aware of general observational evaluation points is good is because if you had a question like describe and evaluate covert observations, you could talk about in general why observations are good. So this is reducing the amount of evaluation points you need to know. You still need to know about an evaluation point for covert observations, but if one of them was a more general one and one was specific to covert, then you've saved yourself some time. Weaknesses, you do get observer bias or observer expectancy effect. So observer bias is where they see what they want to, so if it fits with their hypothesis, or what they expect to see. So for example, the example I use all the time, if we're looking at aggression in between the genders, so between boys and girls, we'd see that we might see a girl putting her hand on somebody's arm might be conceived as affectionate and gentle, whereas a boy touching another child's arm would be seen as pushing, so aggressive. And it's because observers expect to see those behaviours, or they're biased, that's what they want to see. And of course this reduces objectivity, which leads to bias and therefore reduces the validity as well, so which is an extraneous variable. Okay, what I'd like to do now is evaluate naturalistic and controlled observations for me, please. Pause the video. Okay, so observations, you've got naturalistic, as well as all the evaluation points we've just talked about, the two observations we've just discussed, the strengths and the weaknesses, observer expectancy effect and all of those things. The other things you could talk about, naturalistic, so it removes relying on people to report their aggression, which we've talked about already. It's also a natural environment, so you get natural behaviours, which increases the mundane realism, which increases the external validity, that we can apply the results to different places. So if it's a very natural environment, then we can take that, we know that behaviour is natural, and therefore we can apply it to other settings that would be quite natural. However, a problem exactly like we spoke about is observer bias or observer expectancy effect. Another problem with naturalistic, exactly like a natural experiment or a field experiment, is we lack control. So it can't be standardised, more difficult to replicate, more difficult to reliability, so we lack confidence in cause and effect. A positive with control, and then we flip them exactly on their head. So it removes relying on people. It's still an observation, so it removes relying on people. However, it's a controlled environment, so it can be standardised and replicated. We can check for reliability, so we can be more confident in the results, that they are due to something that we've looked at, as opposed to chance due to fluke. The environment is altered, so that might lead to unnatural behaviours, which reduces mundane realism, which reduces external validity, and then of course observer bias or observer expectancy effect, which we've already talked about. Same thing again, write down everything you can for participant and non-participant observations. If you pause the video here. Okay, I've been doing the excellent formatting of these slides, as you can see. So strength, again, it removes relying on people's relying on people reporting their behaviours, so it's quite natural behaviours. Another strength is you can interact very closely, so you might be able to develop ideas of motivations. That gives more detailed data, so we can be more confident that we're measuring what we claim to measure. Problem is observer bias or observer expectancy effect. And we also have observer effect, so they could alter either on purpose or accidentally the behaviour of the participants, because they can directly be involved with them. So if they were looking at team building, they wanted to see gender differences between men and women and who was more likely to take a leadership role, for example, they could purposely start to talk over women whenever women tried to say something, if they didn't want women to be leaders, or they might purposely talk over men if they wanted to encourage the women to be the leaders, and they might do that on purpose, or they might do it by mistake. This of course leads to very unnatural behaviour and potentially even to man characteristics, which therefore reduces the validity. Non-participant, it removes relying on people. So strength is it removes relying on people, which we've talked about. Strength is there's no observer effect, exactly as we've just discussed. This time people can't influence people's behaviours. There is observer bias again, but you aren't interacting, so you might miss details. That reduces the amount of data that you have, and therefore reduces the validity of the study, because we can't be confident that we're measuring what we're claiming to measure if we don't have enough detail. Next one, could you evaluate overt and covert observations for me? Pause that here, the video here. Okay, so once again, excellent formatting skills from me. Okay, we've got covert, so again, positives, because it's an observation, you don't have to rely on people to put their behaviours, it happens. Covert removes observer effect, so because they don't know they're being watched, they don't alter their behaviour, they don't feel uncomfortable. So if you ever feel like somebody's watching, you think, right, act naturally, and then you think, what's acting naturally actually like? So it doesn't alter their behaviour, more naturally increasing the validity. Problem once again, observer bias, so you know this is something you're aware of. However, they are unaware, so that does mean they can't give informed consent, which causes ethical issues, so it can be harmful to them. Of course, it removes their right to withdraw if they don't know they're taking part, less likely to be approved by an ethics committee. Strength removes relying on people for their reporting their behaviours. They are aware, so they can provide informed consent, makes it more ethical and less likely to experience harm, therefore increasing the likelihood that it will be passed by an ethics committee. Observer bias, observer effectancy expect, increases, it says order effect, that's not right. It increases observer effect, apologies, increases observer effect because they're aware that they're being watched. They might alter their behaviour, which makes it very unnatural, therefore lacking validity. Next one, note down everything you can think of for self-report. Pause the video. Okay, if you want to get out a pen and note down anything that you missed. So we've got self-report, a method in which a person is asked to state or explain their own feelings, opinions, behaviours related to a given topic. So this is where people tell you, oh, I'd probably do this, or oh, I feel like this, and so on, for that one. Okay. There are two examples. One of the examples is questionnaires, a written set of questions assessing people's thoughts. You've got open questions, so that elicit lots of detail, you collect qualitative data, and closed questions with a particular set of answers, so collecting quantitative data. You also have a Likert scale, which is a rating scale, which is usually 1 to 10, or strongly agree to strongly disagree. You've done all of these, so you'll all be aware of them. Interviews, you've got a live or face-to-face encounter where you ask a certain set of questions. You've got structured, where the questions are preset, and unstructured, where the questions develop as the interview goes along. Can you evaluate self-report as a whole? So not the specifics, so why is it better or worse than observation, for example, would be a good way to go. Think about strengths and weaknesses that we talked about for observations. Are they flipped on their head? If you can pause the video here. And then we have self-report. So strength, insight into people's motivations, no need for inference. We don't need to infer or assume, so we don't need to observe behaviour and think, oh, they probably thought this. We can ask them directly, they can tell us and we'll know. And of course that increases the validity. Although a problem is social desirability, which reduces the validity. So giving socially acceptable answers. For example, how many sexual partners have you had? Women are going to answer one way, men are more likely to answer another. Are you aggressive? Are you violent? Men would answer more one way than women, who would possibly sway towards the other. Very stereotypical examples, but kind of the traditional ones that we might give. And of course that's an extraneous variable which decreases the validity of our research, making us less confident of cause and effect. So can we be confident that it's actually number of brothers and sisters that we have that's assessing our violence, when men and women gender might be the thing that's affecting it, which we don't want it to be? Can you evaluate interviews and questionnaires in general, so not the specific types yet, but can you evaluate interviews and questionnaires, compare them, which is better and which is worse, and what are the problems with each? Pause the video. Okay. So, excellent. Once again, brilliant formatting. So, questionnaires can distribute to a very large sample. If that was all you said, you wouldn't get the marks. You need to expand and give more detail. So you can distribute to lots and lots of a very large sample, therefore collecting a more representative results, which therefore takes into account more participant variables, increasing the population validity and therefore making it more generalisable. They might be less self-conscious, so about sensitive or embarrassing information they might not want to tell the interviewer, so questionnaires might reduce social desirability bias, which increases the validity because they might be more comfortable to feel more honest. However, they rely on self-awareness. Motivations, they might lack accuracy and understanding. It's measuring participants' interpretations instead of what's actually the case. They might say, exactly as we said, oh no, I'm not an aggressive person at all, I'm not violent, but if we put them into an observation we might not see that was the case. Strength of interviews, we can see cues and body language, so increased level of data, which increases the validity and the honesty of it. We've got interviewer bias, so the interviewer might ask leading questions, alter the way that people are understanding things with body language, so if they start saying something they want, leaning forward and going yes, 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 whereas if it was something they didn't want, if they found quite boring, they'd lean back and go, oh yeah, yeah, so that would be something, therefore reducing the validity. It's also very time consuming, so not a great one to use, but you need to expand on these further, you can't give the basics. So time consuming individually or in very small groups, so you give a very small sample which isn't very representative, so reduces the population validity and therefore you cannot generalise. Can you evaluate structured and unstructured interviews for me, please? Pause the video here. Okay, Strengths. It gives us an insight into people's motivations, so there's no need for inference, so that would be all self-reports across the board. Gives an insight into that, we don't need to infer anything. Structured interviews, because it's an interview, we get cues from body language automatically. It's standardised, so it allows us to replicate. However, one second. Apologies, I thought there was a slide wrong there, but of course I should have more faith in myself because I never make mistakes on a PowerPoint. So therefore the strengths, the weaknesses of a structured interview are social desirability. So that could reduce the validity. We might be influenced by social desirability, not want to be honest about certain things, which is a problem with all interviews. We might also have interviewer bias, which is something we've already discussed. It's very time consuming, and also we can't deviate from the script, so therefore we might miss information because we're not able to deviate or move away from the script. You might think, oh, that's really interesting, I want to explore that more, and you can't do that. Okay. Then we've got unstructured interviews. So again, all of the strengths of the interviews, insight into people's motivation. You can get cues from body language, but the strength is you can deviate from the script. You can explore things in a little bit more detail. However, problems with social desirability bias, interviewer bias, and time consuming, as we've said before, but also they're not standardised. I don't know why that's a plus, it should be a minus. It's not standardised, so therefore it's very difficult to replicate, so you can't check for reliability, you can't check whether the results were a fluke or not, because you cannot complete the experiment in exactly the same way again. Describe correlation, so write everything you can think of for a correlation down in one colour, then get the other colour pen out ready to add anything you've missed. Pause the video here. Okay, correlation, so it's looking for a relationship. If it says about relationship, then it's a correlation. Correlations don't have an IV or a DV or anything like that, they have covariables. If you have a correlation coefficient, so if you have to analyse the correlation coefficient, there are two things you need to be able to tell me, whether the strength and the direction, so whether it's strong or weak and positive or negative. So the direction is indicated with a plus or a minus, obviously, so if it's a plus it's positive and if it's a minus it's negative. And then strength or weakness, so remember it's 0.01 or 0.1 or it's 1. So very weak correlation that probably wouldn't be considered significant is 0.1, possibly 0.2, 0.3, 0.4, and then 5, sort of 5 and 6 kind of in the middle. Then I think 7, 8, 9, 0.78, 0.7, 0.8, 0.9 would be, or 1 would be an incredibly strong positive correlation. So don't forget that you could be asked to, the question could be, what does a correlation coefficient show us? And you would say the strength and the direction, or you might be asked to interpret one. So you might be given a number like minus 0.7, you'd say it was a strong negative correlation. And then evaluation points. So its strengths are they're very easy to replicate and repeat. Take the data, you do it again, and check the same information. And also they allow us to conduct research that is wouldn't be ethical to do an experiment on. For example, we want to look at the correlation between heart disease and smoking. Well, you're not going to get 50 people and ask them not to smoke, and 50 people and tell them to take up smoking and see who develops heart disease first. You're going to conduct a correlation between the number of people, the amount of cigarettes people smoke, and whether they develop heart disease or not. Weaknesses, the covariables, the way they're measured might lack validity. So a perfect example of this would be intelligence being measured by circumference of skull size maybe, anything like that. Poor, weak covariables lacking validity. And then also correlation does not prove causation. So just because two things correlate doesn't mean that one causes the other. So for example, Nicolas Cage films and number of deaths in swimming pools or something like that. Remember Spurious Correlation, the best website ever. That's an example of those. So add anything on that you might have missed from correlations, and I think that is, oh no, or almost. So that was the end of all of our AS content. Now we're going to have a quick look at our A2 content. These are things that people really struggled with. So can you describe content analysis, tell me what it is, and then the process of conducting the two different types. So name the two different types and tell me how you work through how you would conduct content analysis. Almost every single group asked me about this. So pause the video. Okay, content analysis, taken directly off the specification. I'll give you this definition since September, start of the year of September. It's the exact wording on the mark scheme. A technique for analysing qualitative data according to themes or categories. So content analysis is always applied to qualitative data. You've got coding, where data can be put into categories and counted, or thematic, where they can be analysed in themes. So coding would be quantitative and thematic would be qualitative. And that wording is taken directly from the mark scheme. So the step-by-step process, which could almost definitely be asked for content analysis, we've got for quantitative coding. First of all, you would sample this. So in the slides that I've used, you were doing an exam question in class, and that had already been done for you in class, but the first thing you would decide is what you were going to conduct content analysis on. So this wouldn't be people, it would be interview transcripts, newspapers, TV shows, social media, whatever it might be. Then you watch or read, look at that information and familiarise yourself with the material. So for example, in this case, a psychologist could have begun by watching films of some of the clips of drivers' behaviour. So this was looking at how distracted drivers got. And then coding. So from here, you would develop codes. So this isn't like behavioural categories. They are essentially exactly the same thing. However, for content analysis, you would call them coding. So potential categories that would emerge. So potential categories. And then tally and analyse that information. So you sample the information, you look at it, then you familiarise with yourself with it, then you develop codes, which you then tally, and then you conduct analysis on those codes. Please look at this carefully and consider what you've missed. And of course for that one, it said in this study, so there was no marks if you didn't engage with the STEM. And then data, qualitative, thematic analysis, so taking it from qualitative to qualitative. And the one we looked at was patient feedback regarding their mental health, and if you look down here, you've got hashtag Dear Mental Health Professionals, and then they analyse tweets with that hashtag. So decide what to conduct content analysis on, and it's tweets in a certain time frame from hashtag Dear Mental Health Professionals, and we think maybe did a hashtag like hashtag Trump or whatever it was when he was running for president, and we analysed and looked for themes. So you select your sample, you familiarise yourself with it, so you read all the samples and identify themes, and then you allocate each tweet to a theme or themes to tweets, and then draw conclusions. So tweets grouped together based on similarity in themes that were identified. So you sample, you look at them, you identify themes, and then you group the sample under certain themes for similarity, and then you draw conclusions. Can you evaluate content analysis for me, please? Pause video. Okay, strengths, it's genuine real life information taken directly from tweets, taken from interviews, taken from newspapers, whatever it might be. And it's so that's strength increases the ecological validity. We can apply it to lots of different places. You can be more confident that it's true to real life, and also it can be replicated. So we can take all the information and we can do a content analysis on it, thematic or coding, and then we give the information to somebody else and say, right, off you go, you do the coding as well. A bit like intra-observer reliability. However, it lacks objectivity and it can be quite biased. We develop the coding, we develop the themes, we interpret the themes the way that we want to. So that's that. So content analysis, not terrible, but a really, really important one. Please be aware of that. It has come up as a thing that students, like the stimulus has been, they want to look at police driving ability or passenger distractions using content analysis. How would they do it? Describe and evaluate case studies, please, for me. Pause the video here. Okay, case studies, so taken directly from the specimen, the mark scheme. A case study is an in-depth study of one person or a group of people over time carried out in the real world. It's ideographic and individualistic, so in-depth, one person or a small group, over time, real world. And then ideographic or individualistic, we know about the ideographic approach. It's all about looking at individuals. And then there's some examples. You've got HM, Little Hans, Phineas Gage and Jeannie. Evaluation, it's very detailed and in-depth data. It's one person at one time, so you explore that in lots of detail, so that's going to increase the validity. They're real-world events, so of course that increases the ecological validity of the data that we have. We can be more confident of applying it to the real world. And also it's very ethical, so we can't think about Jeannie. We couldn't, as psychologists, have removed all, to find out about nature or nurture, we couldn't have removed all the nature, all the nurture from somebody's life, so we couldn't just get have them be born and then lock them in a room. However, so ethically as psychologists we wouldn't be able to do that. However, unfortunately it happened, and we were able to take advantage of that by looking at her experiences in detail, so it allows us to be approved by ethic boards. A weakness, don't know why I've got a plus next to it, is small sample size, so not very generalisable. And we're relying on retrospective data as well. So data, can you tell us 10 years ago what was little Timmy like, whatever it was, whatever it might be, and very, very difficult to replicate as well. So it's not been standardised. You're not going to find Genie. Hopefully we'll never find an example like Genie ever again. So you can't use those, you can't replicate it and see if you find the same results. And also researcher bias here. So I don't know if you can remember in the video, but the female psychologist that was allocated Genie became extremely attached to her, wanted to adopt her, which is going to influence the way that she reports findings because of that attachment there. And when you spend a lot of time with one person or a small group of people, there's always going to be some kind of subjectivity that goes on and some kind of bias. And that is the end of all the research methods in psychology. Have another look for the other. There are 3 other revision PowerPoints that will be structured in a similar way.